Right now, Instagram is processing 500,000 likes per second. But those likes don't hit the database immediately. They get dropped into a message queues, a digital waiting room where requests line up. Each like waits its turn, gets processed in milliseconds, and if Instagram's servers crash, the queue remembers everything. No lost likes, no duplicates, just a perfectly ordered line that never forgets. Imagine a restaurant kitchen during dinner rush. Orders are flying in. Table 5 wants pasta. Table 8 needs burgers. Table 12 just ordered dessert. If the chef tried to cook everything at once, chaos. Food burns. Orders mix up. So what does every restaurant do? They use a ticket system. Orders get clipped to a rail. The chef grabs the next ticket, cooks it, done. That rail, that's a message queue. But why can't apps just handle requests directly? Here's the problem. Your food delivery app. Lunch rush hits, 10,000 orders at noon. Your server handles 100 per second. Without a queue, those extra requests just disappear. Error messages, failed orders. With a queue, every request gets saved. They wait in line. Your server processes them at its own pace. Nobody gets dropped. Message queues give you 3 superpowers. First, decoupling. The part that receives orders doesn't have to be the part that processes them. They're separate. Second, persistence. If your server crashes, the queue remembers. It's written to disk. When it reboots, it picks up right where it left off. Third, load leveling. Traffic spikes don't kill you. The queue absorbs the spike. Here's what happens under the hood. Your app sends a message, a new order, to the queue. The queue is a separate service, like RabbitMQ or Amazon SQS. That message sits there until a worker grabs it. Workers are little programs that constantly ask the queue, "Got anything for me?" They process it, update the database, send an email, then tell the queue, "I'm done." The queue deletes that message. Next. Some queues guarantee order. First in, first out. A FIFO queue. Like a line at Starbucks, you can't skip ahead. But some queues don't care about order. They want speed. Multiple workers grab messages in parallel. Faster, but no guarantees on sequence. Instagram likes? Order doesn't matter. Bank transactions? You better keep them in order. What if a worker crashes while processing a message? Most queues use acknowledgment. The worker grabs a message but has to confirm, "I finished this," before the queue deletes it. Worker crashes before acknowledging? The queue puts that message back in line. Another worker picks it up. This is why you sometimes get duplicate notifications. The queue isn't sure the first attempt worked. Better safe than sorry. Let's talk scale. Uber processes millions of ride requests per day. Find drivers, calculate price, send notifications, all through queues. Slack sends billions of messages. Every single one hits a queue first. Netflix encodes every video using queues. One message per encoding job. It's not magic. It's really good plumbing. So what tools do developers actually use? RabbitMQ. Open source, battle-tested, the classic choice for routing messages to specific workers. Kafka. Handles millions of messages per second, built for streaming and event processing. SQS. Amazon's managed queue, no servers to run. Redis. Works as a simple queue when you don't need the heavy features. Different scale, different tool. But here's what we skipped. When you send a message to a queue, how does the queue know where to send it? How do workers find the right queue? And what happens when you have 100 queues all talking to each other? That's service discovery, the phone book that keeps distributed systems from getting lost. And that rabbit hole goes deep.